Stars Algebra students, Mr. Lawrence here, and we're going to be graphing quadratics. Yeah, we've been doing all these things with quadratics. We've been solving them by factoring, solving them by the quadratic formula, and there it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we also solve them by completing the square. Now, whether you realize it or not, I can't remember if I mentioned it. It's so weird to not actually see you and interact with you. But whether you realize it or not, solving a quadratic is finding the solutions or the zeros. See this word I have over here? The zeros. In other words, it's the place where the y-coordinate is 0. Yeah. So finding a solution to a quadratic is finding the place where the parabola, that's what the graph will look like, a parabola, or maybe it'll be a parabola opening downward, where the parabola, not parabola, parabola, crosses the x-axis. Yeah, that's what we're after. We're after the place where the parabola crosses the x-axis. Say that with me one time, parabola. Now, all the parabolas that we graph will have a vertex, which is either a highest point or a lowest point. So the vertex would be here, or the vertex could be there, okay? And they're going to have a line of symmetry. Yes, parabolas are going to be perfectly symmetrical. Your body is symmetrical, but not perfectly. Like, you know, if I drew a line down your face, like cutting it exactly in half, a right half and a left half, you might have a freckle on your left cheekbone that you don't have on your right cheekbone, okay? Don't look too closely at this, but your ears aren't exactly the same level, okay? They're slightly off. You can notice different things about your body like that. But you're roughly symmetrical. People are. They're not perfectly symmetrical. But in math, the parabolas are perfectly symmetrical. So let's see how to graph parabolas. Say that with me, parabolas. Well, the first thing I want to do is I want to figure out how many times this parabola is going to cross the x-axis. So I'm going to use the discriminant. Remember the discriminant? It can tell us how many solutions there are. It's also going to tell us how many zeros there are. Zeros and solutions are synonyms. But not cinnamon. No, not cinnamon. I know I'm hungry too. But it's also going to tell us the roots. The terms roots, I almost said synonyms. Roots, solutions, and zeros are all synonyms. Yes, they are. They all mean the same thing. They're the place where the parabola crosses the x-axis. And the discriminant is found right here, right? The b squared minus 4ac. Just a quick review on that. When b squared minus 4ac was greater than 0, we had two solutions, or in this case, two zeros or two roots. When it was equal to 0, we're going to have one solution, right? And when it's less than 0, we're going to have 0 solutions, meaning the parabola will not cross the x-axis. All right? So the first thing I'm going to do is I'm going to go looking for A, B, and C. Hold on here. There we go. There's my equation. So let me get back into calligraphy pen. I like my calligraphy pen. And we'll go A, B, C. Easy as 1, negative 7, 10. Right? And then I'll use the discriminant. B squared minus 4AC. Okay, so we get 49 minus 40, which is 9. So I know there are two solutions. Incidentally, since 9 is a perfect square, that means that we could find the solutions by factoring. I don't care how you find the solutions or the zeros or the roots. You can do it using the quadratic formula. You can do it by factoring. It doesn't matter to me. I think I'm going to spend time on factoring because that tends to be something kids forget about. Seems to give them more trouble. So I'm going to come down here and I've got what? X squared minus 7x plus 10, and I'm going to make that equal to 0. And then when I factor it, I'm going to get x minus 5 in one quantity and x minus 2 in the other quantity, and therefore x is going to equal 5 or x is going to equal 2, right? I did that kind of fast, but I expect you to know how to do it. Well, 5 and 2. Those are the places where the parabola is going to cross the x-axis. So I'm going to mark right there, and then 4, 5 should be right there. Now, they are all perfectly symmetrical, as I mentioned. And you see how I have highlighted in blue, negative b over 2a? The negative b over 2a will find me the x-coordinate of the vertex of the highest or lowest point of the parabola. Yeah, lots of vocabulary in this video. So I am going to do negative b over 2a. X is going to equal the negative of b over 2a, which would be 3.5, right? Which means that the line of symmetry is going to be x equals 3.5. Every point, well, not every point, that doesn't really make sense. Let me get the line of symmetry drawn in here. It's not really a part of the graph, but I'm going to show it. So 3.5 would be right there. The parabola is going to be perfectly symmetrical about that line. Now, it's not a part of the parabola, but it's the line of symmetry, and its equation is x equals 3.5. Remember, it's not 3.5, it's x equals 3.5. All right, so there's the line of symmetry there. Okay, now if I can find my vertex, I can go ahead and finish graphing this parabola. It's actually pretty easy. So I'm going to the equation y equals x squared, so 3.5 squared. I'm substituting, right? Minus 7 times 3.5. Okay, and what is that? Plus 10. Oh, I think that's right. I'll have to check my math on that. That's going to be 21, 24.5. By the way, did you notice something right here? This is kind of crazy. I haven't quite figured out why, but look at this. The one is half of the other. Do you see that? That is going to happen a lot. I just think it's a cool in a math geek kind of way. Just keep watching for it. Watch, it'll happen often. All right, so that makes this math easier because that makes this negative 12.25 plus 10. So the y-coordinate of the vertex is going to end up being negative 2.25. So let's see, negative 2. Uh-oh, my mouse is acting up. And 1/4, maybe right about there. That's my vertex. 3.5, negative 2.25. Okay, now you're going to laugh at me because it is very difficult for me to draw my parabola with the airliner. So I'm going to do the best I can. You should make it a nice, pretty U, not a V. And these curves should not go vertical. Okay, but there it is. I've got 3 points, and there is my parabola. Now, you can check your work on Desmos, and it will look much prettier. So let me get to Desmos here. Desmos.com. Dun, dun, dun. And my equation was y equals x squared minus 7x plus 10. And there you go. Look at that. My first 0 is at 2, 0. My next 0 is at 5, 0. Look at my vertex. 3.5, negative 2.25. There you go. And there's your parabola. And of course, it goes forever and ever and ever and ever and ever and ever and ever. And it does not go vertical, even though on the computer it starts to look like it does. All right. Very, very good. Okay, let's do another example here. Oops, that's not the example. There it is. All right, now I have y equals negative x squared plus 9. All right, first of all, I want to find out how many zeros I have. So I'm going to use the discriminant. So I'm going to need A, B, C. Don't get fooled on this one. Equal as easy as 1, 0, 9. Oops, I made a mistake. Negative 1, 0, 9. There we go. So now I'll use the b squared minus 4ac, the discriminant. Okay. And I will have 0 squared minus 4 times ac, which I believe is going to end up being 36. This one is also factorable because I got a perfect square. If it wasn't factorable, I would use the quadratic formula. I would go x equals the negative of b plus or minus the square root of the discriminant. I wouldn't waste my time redoing the discriminant. I just did it. All over 2a. Watch your negatives there. Okay? And so when I get my x-coordinate of the vertex, it's going to be 0 plus or minus 6 over negative 2. So, oh, this isn't the x-coordinate of the vertex, excuse me. This is the, these are the zeros, or the roots, excuse me. All right, so I'm going to have 6 over negative 2, so I'm going to get negative 3, or negative 6 over negative 2, positive 3. So this is going to go here and here. Now, because of symmetry, I know the line of symmetry is the y-axis. Yeah, because they're zeros, they have to be the same distance from the line of symmetry. But it's not a dumb idea until you're really good to go and check that. So to find the x-coordinate of the vertex, I use x equals negative b over 2a. And when I do that, I'm going to get 0 over 2 times negative 1, which is just 0. So my x-coordinate is 0 of my vertex. To find the y-coordinate, I'm simply going to substitute that in to this equation, which will give me the vertex of 0, 9. Right? 0, 9. So that would be right here. Ooh, do you notice something? This parabola, it's going to open downward. I knew it was going to open downward. Are you writing this down? I knew the parabola would open downward. I'll bet you Antonio can tell you because a was negative. So if a is less than 0, a is negative, then the parabola opens downward. Yeah, every single time. If it's a quadratic equation and a is less than 0, the parabola is going to open downwards. All right, now my axis of symmetry, if you want me to put it in, is just going to be the line x equals 0, right? I should use a different color there. There we go. So it's going to do that. So the axis of symmetry is x equals 0. And then when I go to draw my parabola, and again, don't laugh at me, it's difficult to do with this airliner. So much easier on pencil and paper. Okay, as best you can, make it a curve and make it so it does not go vertical. And there you go. All right. One last one I want to do with you is this one, because when you do A, B, C, you get 1, 0, 4, and when you do the discriminant, you get 0 minus 4ac, which is negative 16, which means there's no solution, which means there's no roots, which means this parabola is not going to touch the x-axis. I can still graph it, it's just not going to touch the x-axis. So I'm going to go ahead and find the x-coordinate of the vertex. X equals negative b over 2a, right? I think I got that right, which is 0. Okay, so the x-coordinate of the vertex is 0. Notice I'm making an input-output table on this one. I normally wouldn't do this. If I put 0 in for x, y is going to be 4, right? So my vertex is at 0, 4. Okay, now I need an x value on each side of the vertex, right? My axis of symmetry is x equals 0. Okay, so I'm going to put 2 in for x. And when I do that, I'm going to get 4 plus 4, and that's going to be 8. Right? I'm also going to put negative 2 in. Why? Because it's the same distance from the axis of symmetry that positive 2 is. Do you understand what I'm trying to say? I'm picking x-coordinates that are equidistant from the axis of symmetry. If I would have picked 1, I would have picked negative 1. If I would have picked 5, I would have picked negative 5 as my second choice. Okay? Now, if I'm smart, I don't have to do any math to figure out the y-coordinate because of symmetry. If I go 2 to the right and it takes me up to 8, Then if I go 2 to the left, it's going to take me up to 8 as well. If you don't believe me, that's fine. You can convince yourself. Negative 2 squared plus 4. You do that math and you're going to get 8. So now I have my parabola, and it's going to look something like this. All right? And again, do the best you can. It's really challenging for me with my airliner. Been doing it for years. I'm just not very good. On the smartboard, I'm fine. On paper, I'm fine. On dry erase board, I'm fine. On your forehead, I'm fine. Just kidding. Okay? But on the airliner, it's very tricky for me. All right, so that is it for the video. You've got some practice problems. And I will say, have a good night, everybody. What's up?